Alright, so now that we've talked about the idea of imaginary numbers and complex numbers, we can continue with working with solving our quadratic functions. And occasionally what's going to happen now and some of the problems we're going to see is that this idea of imaginary numbers is going to reoccur because we now know and understand that every quadratic function has to have two solutions. They may not be two real solutions, but there has to be two solutions according to the fundamental rule of algebra. So, a quick review on something we've talked about previously. When we have a perfect square, which is what this is, I know this is a perfect square. It could be x plus 2 times x plus 2. This is the same thing. Or x plus 2 squared equals 0. When we're solving a quadratic equation that is a perfect square, we can use those perfect squares to make solving this a lot easier, rather than having to use any kind of specific formula or try to factor it out. We immediately know the factors and we can solve it right away. So we'll do the square root on both sides. X plus 2, because that cancels out, equals 0. Now what we'll do to solve this is just subtract 2, and x equals negative 2. Now if we were to graph this, we would see that there's a solution at negative 2 rather, and then the parabola would, look something like this. Now that's only one solution. In this example, I'm not really worried about finding that second solution and using the fundamental theorem of algebra to show how that works. This is just a review on perfect squares, because what we're going to look at today is how to take a quadratic function that is not a perfect square and complete the square. We're going to force any function to be a perfect square so that we can solve it in a much easier way. So we'll take this example. So x squared plus minus 6x plus 3 is not a perfect square. To be a perfect square, 1 has to be a perfect square, which it is, but 3 is not. So this is not a perfect square. But what we're going to do is move the 3 to the other side. So x squared minus 6x equals negative 3. And we're going to fill this space in with a term that makes this a perfect square. And the way we're going to do that is by taking half of this term, so negative 6 divided by 2, that's negative 3, and then we're going to square it. Negative 3 squared is 9. So we're going to plug 9 into this, and this is now a perfect square. We have x plus 3, x minus 3 equals, now hopefully remember, biggest rule of algebra, what you do to one side you have to do to the other. So if we add a 9 here, we need to add 9 over here. So negative 3 plus 9 is 6. Now we can solve this equation. Oh, and actually I made a slight mistake over here. Well, let me just rewrite this. This should be x minus 3 times x minus 3 equals 6, or just simply x minus 3 squared equals 6. So now we can solve this. square root x minus 3 equals plus or minus, the square root of 6 is about 2.45. And now we can use this equation to find our two answers. So we'll add 3, and so we're going to do 2.45 plus 3. And we're also going to do, let me switch colors so we can differentiate here, negative 2.45 plus 3. Here we have 5.45. And here we have 0.55. And like the fundamental theorem of algebra says, there are our two solutions. So rather than trying to factor this, we force it to be a perfect square so that we can use our rules of a perfect square function and make solving this a lot easier. Now, what I also want to do